I'm on page 4. And that is cosine squared theta minus 1 over cosine squared theta minus cosine theta. Let's take a look at the top first. Is there any way we can factor the numerator? Oh, sorry. Is there any way we can factor the numerator? We already had something similar twice. This is the third time the same thing.
That could be sine squared.
Yes, it could be sine squared, but let's factor it for now. Why? Because there is no sine here. So let's just factor it. How do I factor cosine squared minus 1? A squared minus b squared. How do I factor a squared minus b squared?
Cosine theta minus 1, cosine theta plus 1.
Perfect. Thank you very much. Good. Now let's focus on the denominator. Do you recommend anything for the denominator?
Factor out cosine theta.
Very good. Let's see what is left in parentheses. Excellent.
Cosine theta minus 1.
The common factors are gone. So now the final form is the numerator, cosine theta plus 1, the denominator cosine theta. Remember, we discussed this when we looked at the long division and synthetic division. This is not a polynomial. Two terms divided by one term, I can always separate it because it's one term in the denominator, right? So I can write cosine theta over cosine theta plus 1 over cosine theta. Because this is 1, cosine over cosine. And what does this equal to? 1 over cosine is the same with which function?
Secant.
Thank you. That's it. So this simplifies to this. Could you leave it in this form? Yes. But it's a fraction. Here, it's not. I think that this is better, a better simplified form than this, but both are acceptable. Now, it says guidelines for establishing identities. We already explained what that means. From left to right, from right to left, or simplifying both. So now let's choose whatever you want to work on. Again, the book has 21 through 102. So let's go back. Would you like to choose? Or I will, or we take them in order, whatever you prefer. Anyone, please?
Just go in order.
Okay. So let's continue with 32. So we have cosecant theta plus cotangent theta multiplied by cosecant theta minus cotangent theta. They claim it equals 1. So this is another trig identity. Does anyone remember this? No, of course not. That's not the issue. In this particular problem, we're asked to show that the left-hand side equals 1. Because there is nothing I can do here. This is the simplest possible form. I could never start from here and go here. I start from the more complicated situation and go to the other side. Do not write 1. Okay? Meaning, this is my left-hand side. Left-hand side. This is the right-hand side. We start with the left-hand side. Any suggestions on cosecant theta plus cotangent theta times cosecant theta minus cotangent theta? A plus B times A minus B. What do you think I should write immediately? A plus B times A minus B. Anyone, please?
A squared minus B squared.
Correct. Very good. So cosecant squared theta minus cotangent squared theta. Perfect. I know something about these two. They are in a relationship. What relationship? Cosecant squared can be replaced by 1 plus cotangent squared. Cosecant squared can be replaced by 1 plus cotangent squared. Now I can write 1, and I can write equals the right-hand side. Done. I started on the left-hand side, and slowly but surely I worked my way to the right-hand side. Step by step, and I recovered the right-hand side, which means this identity was established. These are never tricky questions, meaning no one will ask you, show that this is an identity and actually it's not. No, this is never going to be a tricky question. No. Establish the identity, it must work. Any questions on this?
Would you show where the paper of the identities, please?
Yes, so they are on the handout. You can open the handout. It's posted. That's another way. And you will have all this in front of you if you open the handout also.
All right, thank you.
Perfect. Good. Moving on. Good. We go on to 38. Okay, 38 on page 5. What does 38 want? Cosecant to the 4th of theta minus cosecant to the 2nd power, cosecant squared theta equals cotangent to the 4th theta plus cotangent squared theta. Okay. So on this side, we have cosecant. On this side, we have cotangent. I don't know whether I can bring this to this. I don't know if I can bring this to this, for sure. But another possibility is I start with the left-hand side and I fully simplify it. Separately, I continue with the right-hand side and I fully simplify it. And at the end, I show that these are the same. The simplified form of the left-hand side is the same with the simplified form of the right-hand side. So let's start. I don't know what that is. It doesn't matter. We start on the left-hand side. So we have cosecant to the 4th theta minus cosecant squared theta. I have no idea many times, and this is okay. This is okay. So many times I may be able to just look at an identity and say to myself, I know what I have to do to get here. But not always. Looking at this, I don't know how to get there at this point. So I'm going to start on the left-hand side and slowly see where I'm getting. Okay, good. What do you recommend we should do? Look at these two so-called terms and say, I think you should do this or that. Cosecant to the fourth minus cosecant squared. What can we do here?
Factor out
Yes.
cosecant squared.
Yes, exactly, exactly. What is left in parentheses?
Cosecant squared
Very
theta minus 1.
Minus 1. I know something connected to this. What do I know? Well, I know that a cosecant squared is 1 plus cotangent squared. So I could replace cosecant squared by 1 plus cotangent squared. So this, just this piece, is 1 plus cotangent squared theta. Okay, so let's see where we're getting. So this is cosecant squared theta, and in here, 1 plus cotangent squared minus 1, I'm going to write it as is. These two will go away. And now I have cosecant squared multiplied by cotangent squared. For a moment, I'm going to look here. This is not cheating. I'm going to look here and say, oh, okay, so if I factor out cotangent squared, I do have the cotangent squared. So let's see what I can do with this. Okay, I go back to my identities because I know there is an identity with cosecant squared, which is this one. I don't even have to go back. It's right here in front of me. So I'm going to replace this by this. Okay. So 1 plus cotangent squared theta multiplied by cotangent squared theta. I will distribute, and I get cotangent squared theta plus cotangent to the fourth theta. And I should have written here the left-hand side, sorry. And if I just simply reverse them, reverse the order, I get the right-hand side. So I'm going to write it again as cotangent to the fourth theta plus cotangent squared theta, and I'm going to write equals the right-hand side. Done. So let's think about the steps here. I took this, I started here. You could have started over there. I started here. So cosecant to the fourth minus cosecant squared, we noticed that we can factor out cosecant squared. Then we remembered that cosecant squared is 1 plus cotangent squared. So we replaced it. Subtract 1, these two go away. So all that is left is the cosecant squared times the cotangent squared. I only want cotangent, so this is okay, but this is not okay. I want it to go away. No problem. Cosecant squared is 1 plus cotangent squared. All I had to do just is to distribute here. And eventually I got cotangent to the fourth plus cotangent squared, which is indeed the right-hand side. So we established the identity. We started on the left, and we showed step by step that we recover the right-hand side. So it will be a mistake to write the left-hand side equals the right. I've seen it in my students' work. Please, you can only peek, but you cannot write the right-hand side anywhere. You cannot copy this anywhere. You have to show that you eventually get to it. So some students write this, equals this, and they copy it here, and they copy it here, copy it. No. That's not what we're trying to do. We're not saying that the left-hand side equals the right-hand side. No. We start by simplifying and performing all sorts of operations to the left-hand side and simplify it and show that indeed it equals the right-hand side. And this is the last step when I say it equals the right-hand side. Okay. Any questions on this problem? Anyone? Yes, please.
So at the end of the problem, when you already like determine that the left side equals the right hand side, you wouldn't write cotangent fourth secant plus cotangent square secant again.
You mean here?
Yeah, right
No,
there.
just
Okay.
equals the right hand side.
All right.
So this shows me that you started on the left hand side, equals the right hand side.
All right. Thank
And
you.
that is very clear because I see it here. It is the right hand side indeed. Very good. Other questions, please? Okay. Should we continue? Anyone? You feel like skipping any of these? It's up to you. You decide.
Can you continue?
Yes. So let's look at 44. And I think I'm on page 6. I am on page 6. Okay, with 44, we have 9 secant squared theta minus 5 tangent squared theta. They say equals 5 plus 4 secant squared theta. I have no idea, and I don't care. I start with the most complicated part. So I start again with the left-hand side. I see secant squared and I see tangent squared. And I know a formula, or I should say an identity for secant squared, is 1 plus tangent squared. So I replace that, 1 plus tangent squared, and then minus 5 tangent squared theta. I will peek. They want secant. Okay. Good. I will distribute 9 plus 9 tangent squared theta minus 5 tangent squared theta. 9 apples minus 5 apples, 4 apples. And because they want secant, that's fine. I will change this back to, remember, it's 1 plus tangent squared alpha equals secant squared alpha. So if I want to solve for tangent squared, I have to subtract 1. So this is 9 plus 4. Tangent squared is secant squared minus 1. Distribute 9 plus 4 secant squared theta minus 4. 5 plus 4 secant squared theta equals the right-hand side. Done. Now, when we peek to the right-hand side, maybe it would have been most probably easier to replace this directly by secant squared minus 1. It would have been a shorter step of theta minus 1. And we would have gotten there even faster. Any questions on this problem? It's not important how many steps you write. It is easier if we choose the shorter one, of course, and more elegant, but it's fine either way. Okay, 48. Any questions on this? Please stop me anytime, please. So in 48, cosecant v minus 1 over cosecant v plus 1 equals 1 minus sine v over 1 plus sine v. Again, I'm going to look at the most complicated situation. Sine is sine, but the cosecant can be replaced by something. Sine alone cannot. Okay, so I'm going to start again from the left-hand side, which is what is the formula or the identity or the ratio that replaces cosecant? Don't say anything, 1 second.